Hi. So there's been a growing number of people posting on the internet, particularly on YouTube, about how they've reduced their myopia by basically progressively wearing a lower prescription each time. And they've, some of them have really gone from quite significant amounts, like, -4 or 5, certainly in one case to 20/20. And I was quite interested. None of them say, well, it was really hurting. And that intrigued me. I do believe what they're saying, by the way. But it intrigued me because, I'm kind of on the other, further along the continuum. So I'm long-sighted, and for long-sighted people to manage with less than you need, it hurts. And one of the things, one of the ways of spotting long-sightedness, whether in children or adults, is it hurts. You get eye pain whenever you look at something. You get headaches, you get neck pain. But this doesn't seem to happen to the people who are overprescribed minus glasses. And you could say, well, maybe it's because it happens very young, but children who are hyperopic very often experience pain when they try and read. So that doesn't quite add up either. So, as I say, it intrigued me. So so I was tempted to find out a bit more about the eyeball, and to ask some questions about why does it hurt if you're there on the continuum but not there, because people who may have started off at -1 diopter, and they'll just go down and down and down and down, and they'll seem to tolerate another minus, another minus, another minus, without any ill effects whatsoever. So to explain this, and that really is a couple of eggs on a plate, but to explain a few figures and dimensions of the eyeball itself, it is pretty much a sphere, and the dimensions are, it is on the whole 23.30 millimeters long. So that's from the front of your eye to the back of your eye. The anterior to posterior, now they say 24 millimeters, and I got this off Wikipedia. Wikipedia's great. So that should mean the front and the back as well, but that's a bit of a different measurement. Top to bottom, 24 millimeters. The transverse, so that means from one side of the eye to the other, that's a 24.2 millimeter diameter. The sagittal So that means from the front to the back is 23.7. But then it also says the eyeball is 23.30 millimeters long, so I don't quite understand why those two measurements are a bit different. But basically it is pretty much even Stevens all the way round. So when, and this is where the eggs come in, so a short-sighted eye, if this eye is looking at the camera, then it will be that shape. Obviously it's very much exaggerated, and a long-sighted eye, if take that as the eyeball, it will be that shape. Obviously it would be a round shape, not a spherical shape. But the point is, when the eye, to view close, the eye lengthens out, and to view distance, it flattens. That's put very simplistically. And with the wearing of minus glasses, the eyeball just lengthens and lengthens and lengthens to accommodate. But here's the rub. A millimetre change in length, that makes a 3 diopter difference. So the amount that the eye has to actually lengthen or shorten to become to focus differently, or to be long-sighted or short-sighted, it's really small. So having said that, a millimetre in terms of what's going on inside your body, that is actually quite big, because inside your body you've got, stuff is next to other stuff, and something moving out by a millimetre can make a really, really big difference. So for instance, I don't know, take your hip. Your hip is a really big joint. Perhaps if it was the ball was a millimetre too big, then it could be quite sore because it'd be rubbing, or if it was a millimetre too small, it could dislocate very easily perhaps. So a millimetre might, obviously it changes 3 diopters, so it makes a big difference. So if you've got, let's say you've got long-sighted eyes, and I'm just thinking aloud here. Actually, these are short-sighted eyes. Now, yeah, okay, so this is a pair of myopic eyes. They're looking straight ahead. Now, stay there, you. What happens if... Okay, so they want to look dead at the camera there, so I'm going to space them apart so you can see. Obviously they have to converge to look at that point, so they turn inwards. So if you can imagine 2 lines coming out there, and then say they want to look at this, which is even closer. In fact, I'll put this here, so they have to turn right in to see that. So that's convergence, and obviously when you're reading, you not only do you have to be able to converge, you have to be able to track along a line. I don't know if you can see that, but I'm going to exaggerate it a bit. So say the line starts there, or actually from where I'm filming, it would start that side, so as the eyes follow along the line. I don't know if you can see, I'm turning these eggs. But that's, as I say, it's greatly exaggerated. That's the myopic eye. This is the hyperopic eye. Now, if you can imagine that turning, that's quite easy. If you can imagine these eyes turning, there's a lot more that has to turn, and let's put the little pink bits in front so it looks like an eyeball at any rate. So I just don't know about that, but the musculature of the eye, so you have two at the back and the front, two at the top and one at the top, one at the bottom, one this side, one that side, and you got one looping kind of round from here, that's the inferior oblique, and then you got one that kind of loops in this S shape round the back from here, and that's the superior oblique. And these ones at the side are called the laterals, so it's the medial lateral. I can't remember all the names exactly, but you got 6 of these little ciliary muscles. Where they're situated, they kind of fit along the eye like this, so they're kind of situated there, and then they kind of go backwards, so they kind of all not meet in a point, but they are kind of positioned like that, or shaped like that, whatever. So it's possible that millimetre change at a certain point, that might be what kicks off eye strain once you get to a certain diopter, if that is your natural state of being. So in a hyperope's eye, then this would be where the muscles would be, so they would be ever so slightly shorter perhaps, I don't know, and then when the eyeball has to lengthen out, and especially when it has to start converging on top of that, maybe it just stretches that muscle more and creates an extra pull because that muscle's a bit shorter and tighter in the first place. I really don't know, but yeah, if anyone's got any ideas about any of the things I've mentioned here, I'd definitely be interested to hear, because I'm intrigued now as to why the hyperopes get eye strain and pain really, really easily, and yet other people can go into quite significant induced myopia without that problem at all.